Hey, Mr. Dressler and Mr. Glennon's room. Hey, you got some side activities that you'll be doing kind of based off of my little video here. And teachers, I'm just going to be essentially going from one task to the next. So when I say, hey, maybe you'll want to pause here at this point, maybe just pause my video, then you can get it back started after your students have completed that task. So I'm just going to kind of go from one thing to the next. It'll make more sense, students, if you have Google Calendar open and you're looking down at the tasks that are outlined beneath Dressler and Glennon. So the basis of today's lesson, yesterday you did the Lego molecules activity. So you kind of did the hands-on part first. Then you'd be thinking of the atom at more of a, what we call a model level or molecular scale. So our learning target for today, and I think I mentioned this maybe yesterday, I had this up on the board, or maybe not, forgive me if I'm doubling up here. Our learning target is develop models to describe the atomic composition of molecules and extended structures. So you were thinking yesterday when you were making, putting Legos together, you were making a model of atoms, a model of molecules. So that's kind of essentially what a model is, a different way to represent something that we cannot see. In our astronomy website projects, you were making a scale model of planets and moons. You drew them to size, even though we can't exactly go out and go to those objects. So we have to make models. You may have drawn a moon phase model when we were in that unit. There are also models of all sorts of things, from skeletons to the interior of the planet to the interior of a star. There's models in all sorts of aspects of science. An atom is just another one that we'll be doing. So the atomic composition. So whenever you see the word atomic, it's referring to something related to the atom, right? Molecules. Remember, that's what is related to whenever we have atoms combined. It could be the same atom or element, like two hydrogens connected, could be two oxygens together. You remember the term, the other word we talked about yesterday, compound? That's when we have different atoms or elements combined with one another. So my goal is that you can make models representing what these would be at the very microscopic level versus the macro level. Macro meaning we can actually see it with our eyeballs. So first thing that I want to do, I just got a little warm up for you. Teachers, your students are going to need 2 sheets of paper. One of them, they can really be like scratch paper. They don't have to be blank on each side. They don't have to be loose leaf. So if you need to distribute materials, you can kind of pause right here. But students, when you're ready, when you have 2 pieces of paper, one of them, I got a challenge for you. I want you to, with your scissors, kind of like the long, like the wide way here, I want you to cut this piece of paper in half as many times as you possibly can. So here's how you would do it. So I'm just going to cut this like so. I'm not cutting this the long way. I'm cutting this like so. So I have 1 piece of paper. I set one of those aside. All right, that's 1 cut. Then I'm going to take this sheet of paper. I cut this one in half. I set that to the side. You can kind of line them up as you cut them in half. So there's 2 cuts. There's my third. Be careful with the scissors. Please do not stab yourself. You see what I'm doing? I'm just setting them to the side. And I continue cutting in half. I challenge you to get 20 cuts. Okay, I challenge you to get 20. That doesn't mean when it gets too small to the point, oh, does that mean do I go back to this other one and keep cutting this in half? No. Okay, you leave all those alone. You'll end up with a very, very small piece of paper on the little tip of your finger. I challenge you to get 20. The best in the other classes was 22. And that's pretty tough to get. That's really small. So teachers, that maybe give them a few minutes. If you get up into the teens, that's a good thing. Okay, I think you can definitely get to like 13 at least. Then it gets a little bit tricky. I'll tell you why we're doing this in a second. So cut away safely. Teachers, when your students are cut it out, you can resume my video. Okay. Anybody get 22? 23? I think like the best ever. And I think students are probably fudging their numbers. I've had students in the past claim that they've gotten like 25, but that's really hard to do. Uh, Reason I'm doing this. Question I ask you. If you had scissors, atomic scissors, that could continue cutting far beyond 20s, how many more cuts would you have to make to get to the size of an atom? Guesses? It's not like some crazy high number into like the hundreds of thousands or millions. I'll narrow it down for you. It's under 100. Guesses? Okay, you would have to cut that piece of paper in half 90 times to get to the size of an atom. Now that number 90 may not seem that large, but just imagine trying to cut that in half 90 times. Maybe you got the 20. 20 was hard to begin with. Imagine doing it 70 more times to get down to the size of one single atom. Okay, that's really small. Next thing, I'll have your teacher, you guys can clean up all that stuff. Clean up all that. Don't just sweep it down on your floor. Put it in the recycle bin. Put those scissors away. So teachers, you can kind of pause right there. When you're ready, start me back up. So after all cleaned up there, what I want you to do with that other sheet of paper is I want you to describe for me in a model drawn form, when you think of an atom, what does it look like to you? Draw me a picture, what you think the atom looks like. And I know whether you've watched any science fiction shows, science TV shows, you've seen models or pictures of atoms in textbooks. What do you think of? Draw it for me. And there will be a prize for the most detailed drawing that I get turned in. The prize is a very special kind of sucker. It's not just any kind of sucker like a dum-dum, a really special kind. And I will reveal the winner after I get to look through these on after school today. Okay, now it doesn't necessarily mean the prettiest drawing, but the most detailed. So do you know anything about the interior of the atom? If so, label it, because models also are detailed in terms of what they're labeling. Okay, so on that other sheet of paper, draw for me what you think the atom looks like. And when you're finished with that, just put your name on it, and your teacher will pick that up, and you'll just get it turned in by the end of class. You don't have to rush to turn it in right now. When you finish with that drawing, then you should be looking back into Google Calendar, and I want you to get your digital science notebook up. Okay. On my screen that you'll see a prompt that I have for you. And if you click that prompt, this is what your new entry is going to look like. Okay. And notice I've put this into a new folder in my digital science notebook because we're on a new unit now. We're not in astronomy anymore. Got to go to this. So when you're in Pages, you should have, again, just your home page, your solar system project, which should be done today. Quantitative data, I'm grading this weekend. Notice I have a chemistry and astronomy here. To make a new page, click that little drop-down arrow in your journal, then you click the 3 dots, then you click Add Subpage. Title it Chemistry. And again, I'm kind of a stickler on it. It should look nice, capitalize the headings. So I have chemistry right here. Then my astronomy, we're not going to be putting entries in there anymore. So take a moment. You can copy and paste this right into yours, or just type in the questions based off of however you want it formatted. Again, to get to this link, to copy and paste it, it's right here underneath the mighty atom. After you have that entry put in, click on the reading. That's going to take you right here. And you should see this really neat building titled the Atomium, which is still, you can still visit it today. It was a World's Fair project back in the 1950s. I think it's in Denmark. it was supposed to be dismantled shortly after the World's Fair of that year, but it is now still reopened. Now you can either do this as a group or you can do this individually. So Mr. Glennon, Ms. Dressler, if you want to read aloud as a group, that's fine. Or if you choose you want to do this individually, that's fine. So before you start the reading, The Mighty Atom, I want you in your digital science notebook to answer this first question. And this is kind of based off of maybe how you drew the atom. Describe for me, what's the first thing that comes to mind when you hear the word atom? Like, hey, we're going to study atoms. What pops into your mind? It can just be, give me a sentence or two. Okay. I understand that you're probably not maybe thinking about atoms on a daily basis. Then after you read, and the reading is just 2 pages, it introduces to you, I think, a different way of thinking of atoms. Pick a quote for me that really kind of you're drawn to, you find interesting, and tell me why. Okay, so you can read that aloud, partners, whole group, that's fine. This is from the book, A Short History of Nearly Everything. When you're finished with the reading, and you've also completed these 2 questions, remember, hit submit. Then, if you have time, I imagine there'll be some time left at the end of class there. If your quantitative data page is not done, you needed to finish up a paragraph there, that's what you can work on, or element flashcards. Or there's some reinforcement practice on building molecules. If you look in Schoology, there's this activity called Build a Molecule, leads you to a simulator where you can do that. Another cool thing that you should really try is, it's linked, it's this first thing called Scale of the Universe. It's a neat simulator that shows the micro and the macro world, micro meaning small, macro meaning big. Once it starts up, you just zoom in and out. And I want you to find the locations of where a single atom would be on this scale, all the way to the visible universe. It has this trippy music in the background too. Another option after that, if you wanted to watch it on your own, that Build an Atom Simulator, that's the one I mentioned, that's in Schoology. How Small an Atom, that's a 4-minute video clip. Just throw your headphones on. It's another good representation of how small atoms are. All right. With that in mind, there's plenty of review material for you to do after you're done with the digital science notebook entry. Hope you have a great weekend. Give me a holler if you got questions. See ya.